Okay, question number 8, maximum mark 8 points. Consider the complex number like this. Express z1 in the form of REI theta form, where r is greater than 0, of course, and the theta is from negative pi up to pi. Okay, this z1 we can draw an Argand diagram easily. So this is the real axis, and this is imaginary axis, and then we can draw square root of 3 over here, and then minus 3. So minus 3 is over here. So this is where z1 is located, and then we can easily find the modulus. Modulus is square modulus z1 of modulus. This is square root of root 3 everything square plus minus 3 is square. So this is the square root of 3 plus 9 equals square root of 12 equals 2 square root 3. And then argument of z1, we can see this is root 3 and this is minus. So this is square root 3, and this distance over here we can say this is minus 3. So we can say argument theta is arctangent minus 3 over square root 3 equal arctangent over this is minus square root 3 times square root 3 over square root 3. This cancels out, only so this is minus square root of 3 equals this is minus pi over 3. So we can say z1. So z1 is r is 2 root 3, 2 square root of 3 e to the I of argument is minus pi over 3. So this is the answer for the first question. Okay, consider the complex number z2 like that. Modulus of z2 is 2 square root of 3, and the argument is 5 pi over 6. The cube root of z2 over z1 are denoted by UVW. To find UVW. So let's find z2 over z1 first, because we know all of these things as a Euler form. So z2 is already, we have 2 square root of 3 e to the I of 5 pi over 6 over z1. We already got 2 square root 3 e to the I of minus pi over 3. So this 2 square root 3 cancels out, become 1, and then this becomes this is by De Moivre theorem, this is this argument minus this argument. So we can say e to the I of 5 pi over 6 minus pi over 3. This becomes plus, right? So this becomes e to the I of 6 on the bottom in common. We got 5 pi plus 2 pi. So this is e to the I of 7 pi. 7 pi over 6. So we got it. And then question says the cube root of this number are UVW. So cube root. So we can say z to the third power, the cube root of this one, cube root of that one. So e to the I of 7 pi over 6. This root, the root of this equation is u, v, and w. So we can make both side with 1 over 3 power. So we got z. So by doing so, we got z equals e to the I of before doing that, we need to do something, right? So not like this. So cube root of that number, we can say cube root of that number is equal to e to the I of 7 pi over 6. We can always add 2n pi, where n is integer, like that. So we can also say g to the third power is e to the I of, let's put the 6 on the denominator together, is 2n pi, now become 12n plus 7 over n pi over there. We can say that. So from now on, at this moment, we can put the power 1 over 3 on both sides, left and right hand side. Left hand side we got z, and the right hand side e to the I of goes in the down there, so it's gonna be 12n plus 7 over 6 times 3 is 18 pi, like that. Because it's cube root, we can just simply plug in the theta is minus pi to pi, so we can simply plug in n equals minus 1 and 0, 1. Yeah, so it's gonna be, the answer is UVW. So let's say U is putting minus 1 there is e to the I of minus 1, so minus 12 plus 7, so minus 5 pi over 18. This is U, and V can be e to the I of putting 0 in there, so it's going to be 7 pi over 18. W is e to the I of putting 1 there, is 17 pi over 18. So UVW is like this number, three numbers. Is this correct? No, the putting 1 is actually not this number. So putting 1 over there is 12 plus 7 is 19 pi over 18. Because 19 pi over 18, this one is greater than pi. What we can do is we can simply put not W is not expressed like that, so you can express W as putting of negative 2 there. Oh no, negative 2, minus 1, 0, 1. So negative 2, put negative 2 there, so it's going to be e to the I of minus 24 plus 7 over 18 pi. We can say that e to the I of 24 minus 24 plus 7 is actually, what is that? Minus 17, yeah, minus 17 pi over 18. So this is W.